Good morning, everyone. So I'm Benjamin Powell.
And I'm Dadisi Sanyika, and I'd like to thank you for joining us today at CDCon for our session. We actually renamed the session, guys. It is Conduit, Reimagining SDLC, Workflow Orchestration. Same talk, though.
So before we dive in, I want to get a quick show of hands. How many of you have worked with 5 or more tools in your delivery pipeline? Okay, that's nearly everyone. Now, how many of you feel that those same tools work seamlessly together?
See, that's what I thought. And so today we're going to talk about that and why that is and what we can do about it.
Let's start with a scenario that we've all experienced. You're deploying a critical update and you need to track its progress in your deployment pipeline. So what do?
You open your Jenkins status to check the build.
Then you go to Artifactory to confirm that the correct artifact was published.
Then your Kubernetes dashboard to monitor your deployment.
Then to Datadog to watch for any performance impacts.
And PagerDuty to make sure no alerts fire.
And if there is an issue, you might need to check Jira, Slack, maybe even Zendesk to see if any customers are reporting any issues.
By the end, you have 8 browser tabs open, you're dealing with 3 different authentication systems, and there is no complete view for everything.
This is the fundamental problem that we are addressing today. In modern software delivery, we have powerful but specialized tools, and they work in silos with no common language between them.
Each tool specializes in part of the delivery pipeline, but each tool speaks its own language and has no awareness of the broader workflow context.
This siloed tooling approach creates several critical challenges for every organization here today.
First, there's a visibility problem. No single view exists of your entire software delivery lifecycle. This creates blind spots where issues can hide.
Second, there's a coordination problem. When tools don't talk to each other effectively, human operators become the integration layer. They manually run the next step or copy information between systems.
Third, there's a governance problem. Implementing consistent policies across disconnected tools means duplicating logic in multiple places, creating maintenance nightmares.
And finally, there's an optimization problem. Without end-to-end visibility, you can't measure, let alone improve your overall delivery performance.
These problems aren't new. The industry has tried to solve this before with traditional orchestrators.
Right. Tools like Jenkins, Airflow, Argo workflows aim to centralize and control the entire process.
But these traditional orchestrators have a fundamental flaw. They try to own the entire workflow.
They force you to define everything in their systems, using their specific syntax, using their pipeline execution models, and their plugins.
And that approach breaks down in face of the modern complex delivery pipelines that span multiple teams, multiple tools, and multiple environments.
The right orchestration paradigm keeps tools focused on what they do best, with a coordination layer just added on top to connect the flow.
And that's where CDEvents comes in.
So let's talk about CDEvents. For those who aren't familiar, CDEvents is a CDF project that standardizes events across the CI/CD landscape.
CDEvents are cloud events, specifically designed for continuous delivery workflows.
The key insight behind CDEvents is that while tools are very diverse, the concepts that they represent are actually quite consistent.
A build started event in Jenkins and a build started event in GitHub Actions represent the same fundamental concept, just with different formats and payloads.
So CDEvents gives tools this shared format to produce and consume events reliably.
Let me give you a quick example. Here's what a completed build event might look like in CDEvents format.
The beauty of this approach is that it normalizes events across different systems. Whether an event comes from Jenkins, GitHub Actions, Circle CI, or any other systems, it can be transformed into the standardized format.
And once events are normalized, they become interoperable. Different tools can understand and react to events from other systems without custom integration work.
So CDEvents already defines a lot of the common events that we see today. So that includes repository events, build events, test event, artifact, deployment, service, and lastly, environment events.
And the specification continues to evolve as the community finds new use cases and event types.
So now CDEvents is a fantastic start for standardizing how we communicate about the CI/CD activities, but really it's only a part of the solution.
Right. Standardized events are necessary, but they're not sufficient. What we need is a way to coordinate and orchestrate based on these events.
So let's talk about what we mean by event orchestration, how it differs from traditional orchestrators.
Traditional orchestrators follow what you might call a command and control model. They own the entire workflow and actively execute each step in sequence.
They typically maintain a central workflow definition that looks like something like in the diagram in this slide.
The orchestrator then executes each step, waits for it to complete, then proceeds to the next step. It's a very linear, sequential approach.
This approach works well for very simple and predictable workflows, but actually breaks down when different teams own different parts of the process or different tools are used for different stages and workflows that might need to adapt based on results or external factors.
Event orchestration takes a fundamentally different approach. Instead of controlling the workflow, it observes and coordinates.
In event orchestration, workflows emerge from events, not from predefined scripts or code. The orchestrator listens, makes decisions, and triggers new actions as needed.
So let me illustrate this with an example in a traditional orchestrator. You might define a build application, you run a test, and then deploy to stage.
So in event orchestration, you'd instead define logic, like on the right here, where the system listens for events such as deployment finished or tests failed and reacts accordingly.
The difference is subtle but profound. In the event-driven approach, each part of the system operates independently, emitting events as things happen.
This creates a more resilient and adaptable system. If your test infrastructure changes, the orchestration doesn't need to change. It just needs to listen for that same test of finished event from the new system.
Event orchestration also naturally handles complex scenarios that traditional orchestrations struggle with. Events arriving out of order, parallel workflows that need to converge, and external events that should influence your pipeline are all handled.
For instance, what happens if a critical security alert comes through from your monitoring system while a deployment's in progress?
In a traditional orchestrator, that's a special use case, and you need to have written code for it explicitly.
In event orchestration, it's just another event with a predefined response, perhaps pausing that deployment until the security issue is resolved.
Events also make it easy to incorporate inputs from across your entire tool chain, not just your CI/CD tools, but also your monitoring systems, your ticketing systems, customer support platforms, and more.
A PagerDuty alert, a Datadog monitoring threshold, a Zendesk ticket, or a Jira status change all can become meaningful events that influence your delivery workflow.
That's the power of event orchestration. It creates a reactive system that can adapt to what's actually happening, not just what you predicted would happen when you defined your workflow.
Now that we understand event orchestration, I want to introduce another key concept called workflow segments.
Workflow segments take the idea of event normalization one step further by standardizing not just an individual event, but entire concepts in software delivery lifecycles.
So let's take build as an example. A build segment would represent all steps that involve compiling and packaging your application.
Regardless of whether you're using Jenkins, GitHub Actions, Circle CI, or something else, the concept of a build remains consistent.
A build segment becomes a defined contract, a standard set of inputs, output, events, and states that any build process can conform to.
For example, the build segment might specify a build started event when the build starts, a build finish event when the build finishes, and the build finish event should include information about the artifacts produced. It should include standard metadata like duration, status, and commit triggering.
This contract becomes a normalized interface that any build system can implement.
And we can define similar segment contracts for standard SDLC concepts, tests for running automated tests, SEA for performing software composition analysis, deploy for deploying to an environment, canary for gradual rollouts, blue-green for maintaining up to production environments and switching between them, and rollback for reverting to the previous known good state.
So each segment has its own contract defining its standard set of inputs, events, outputs, and states that are associated with that concept.
This standardization creates some powerful capabilities.
First, it makes tools interchangeable. If both Jenkins and GitHub Actions implement the build segment contract, then you can switch between them without changing any downstream systems that uses your build process.
Second, it enables more meaningful governance. Instead of writing tool-specific rules, you can define policies at the segment levels. All build segments must include security standard, or all deploy segments must use a canary approach.
Third, it creates knowledge portability. When your team understands a canary segment, they understand the concept regardless of what tool it came from.
And fourth, it enables meaningful end-to-end metrics. You can measure time from commit to deployment consistently, even if different projects use different tools for building, testing, and deploying.
So workflow segments define a semantic model over your pipeline, which captures the intent behind each step, not just the events that it emits.
Now, let's bring this concept together and introduce Conduit, an event-driven SDLC workflow orchestration platform that combines CDEvents and workflow segments to solve the challenges we discussed.
So Conduit acts as a central nervous system for your software delivery process, observing events from all your tools, understanding them through the lens of workflow segments, and coordinating actions based on your defined policies.
Let's look at how Conduit works.
So at its core, Conduit has several key components. Event listeners that consume events from your tools, an event matcher that identifies those relevant events and then maps them to workflow segments, a segment contract loader that maintains the definition of those standard segments, then an event router that determines what should happen next. There's a DSL executor that can trigger actions as needed. Then lastly, there's an observability layer that visualizes the entire flow.
So here's what a simple workflow might look like in Conduit. A developer pushes code to GitHub. GitHub triggers a Jenkins build. Jenkins emits build events that Conduit captures. Conduit maps these events to the build segment. When the build segment completes successfully, Conduit triggers a deployment in Argo CD. Argo CD emits deployment events that Conduit captures. Conduit maps these events to the deployment segment. Conduit maintains the state and the relationship between these events and segments.
But the real world power comes from when we add complexity to real world scenarios.
Let's say that during your deployment, a Datadog alert fires, indicating a high error rates.
Conduit would simply just capture this as an event, and based on your defined policies, might automatically pause the ongoing deployment, create a Jira ticket that's assigned to the responsible team, send a Slack notification to the on-call engineer, or even trigger a rollback if an error threshold is met.
All without any human interaction or custom integration code.
So Conduit's event-driven nature makes it excellent at handling complex workflow patterns.
For example, fan out and fan in patterns with multiple parallel processes that need to be completed before proceeding.
Or conditional workflows that adapt based on context, taking different paths for different services or environments.
Or approval workflows that incorporate human decisions alongside automated processes.
So let's talk about the industry impact of a tool like Conduit.
First, it preserves your investment. It preserves your investment in specialized tools, excuse me. You don't need to replace your existing CI/CD systems. Conduit works with them, not instead of them.
Second, it breaks down silos between teams. Whether it's security, operations, development, and business stakeholders, they can all interact with the same workflow with their own preferred tools.
Third, it enables true end-to-end governance. Policies can be defined centrally and enforced consistently across all tools and teams.
And then fourth, it provides the visibility that's needed to make the optimizations for your entire delivery pipelines. So it identifies bottlenecks and inefficiencies regardless of what tools it is using.
In essence, Conduits creates an abstraction layer for software delivery, similar to what Kubernetes did for container orchestration.
Instead of focusing on specific tools, teams can reason about the delivery process in very simple and standardized portable terms.
And just as Kubernetes lets you define what you want rather than how to do it, Conduit lets you define your workflow in terms of what should happen, not how each specific tool is configured.
So, as we wrap up, let's emphasize that event-driven orchestration is not a new concept. It builds on well-established patterns from event-driven architecture.
What's new is applying these patterns to SDLC workflow in a standard way with CDEvents and workflow segments.
The reality is that our delivery pipelines are already event-driven. They just lack the standardization and coordination layer that Conduit provides.
Every day, events flow between your systems. A commit triggers a build, a completed build triggers a deployment triggers monitoring checks, and an alert might trigger a rollback.
Conduit simply makes these implicit events explicit, standardized, and actionable.
That's the promise of Conduit. Oh wait, sorry. Yeah, go ahead. That's the promise of Conduit. Not to replace your tools, but to help you work together in harmony.
So, I would like to thank you all for your attention, and we'd be happy to take any questions now.
And we invite you to check out the CDEvents specification at cdevents.dev to learn more.
And then we have links here and a QR code that goes to this hero page that has all the links. So you can go ahead and check out the Conduit, look at the README, which is basically just kind of like a copy of these slides. There's also the Slack under CDEvents. You can join our working group. We meet on Mondays and then bi-weekly on Tuesdays, which is the implementation SIG, talking about how we go about implementing things. And then the Monday one is the spec SIG that talks about the specification.
Any questions? All right, cool.
Yeah, good job. All right, we had time for a question. Yes.
How does authorization work for event providers? Like what prevents one GitHub action from masquerading as another or masquerading as like a PagerDuty event?
Yeah. So this is a proposal that I've actually been writing for quite a little bit now. And this is going to introduce a new concept, not only just in CDEvents, but also in cloud events, that gives a signature to events. So for an event to be masqueraded or mirrored, like mimicked as someone else, they would need to have those keys. And then the architecture would need, depends on your company, but basically you would have some sort of key, or key management system that would take those keys, know how to I guess give it to the correct person, consumer, and then they can go ahead and then verify that the signatures are correct and are in fact coming from the right person.
Yeah, you can mention that it's the DSE, the envelope? You want to mention the envelope?
Oh yeah, so so the signature is going to be implemented in a new, it's relatively new, it's like 4 years old, but it's called DSSE. So DSSE is a new, it's called Dead Simple Signing Envelope, so please look it up, but that's what we're going to end up using. And like I said, please keep a lookout for it, so that's how we're going to solve that problem.